Instadapp just designed a lending protocol that's built entirely as a Uniswap V4 hook. In this video, I'll explain how it works based on the article that they put out. Watch till the end if you want to learn about negative liquidity, inverse range orders, and how these new concepts are used to build this protocol. You can find me on Twitter, and I also write a newsletter where I look at different protocols and companies in crypto and talk about what they're doing from a product perspective. Let's get started. So Uniswap launched V4 earlier this year, and the main feature that was really interesting is of course the hooks, which are basically ways of inserting logic before and after actions like swaps and adding liquidity. With the announcement article came a few ideas of simple hooks that could be implemented, such as dynamic fees, time-weighted average market makers, on-chain limit orders, and so on. But there's an entirely new category, which is basically protocols that are built entirely as a hook. And this is, I think, one of the first examples of that. And thanks, Ben Bash, for introducing this concept to me and sharing this article. It's been really fun to break it down. So let's get into it. So Instadapp is a DeFi aggregator, and this is an idea that they just put out. So effectively, this is a limited lending protocol in some sense, as we'll see. But the features that they are putting forward here is a flexible liquidation threshold. So users can decide their liquidity threshold, which is really interesting. Typically, lending protocols in DeFi have a fixed collateral ratio. In this case, that there's more flexibility there. Based on that, you can drive a borrow rate. So that's also flexible accordingly. There's boosted income to Uniswap Liquidity Providers. So they do have an incentive in participating here. This is an oracless protocol. So it uses the spot price that's implicit in the Uniswap pool to trigger basically liquidations or their form of liquidations. There's also a 0% liquidation penalty, but there is a decay fee that's being paid out. And then there's also this idea of transient liquidation, where liquidations can be reversed in the same way that range orders are reversed in Uniswap V3. So how does this actually work? Well, let's look at a traditional Uniswap V3 position. So we start by LPs adding liquidity is normal. So in this case, on the left-hand side, we see the ETH price, and we see 3 points on the price curve in an ETH USDC pool. We see prices from 1,500, 2,000, and 2,500 USDC per 1 ETH. So in this case, the liquidity provider has added some liquidity in the range from 1,500 to 2,000. So far, so good. So far, this is just how Uniswap V3 works. But now we're adding a new type of role, which is a borrower. And we're also adding a new type of role, which is a lender. So a lender here would say, hey, I'm putting forward some USDC in exchange for an interest rate that I can gain. And then the borrower is going to put out some Ether as collateral in order to borrow that USDC. And this is where the interesting part comes in. In order to kind of build this collateral-based position, the borrower basically puts up what's called as negative liquidity or an inverse range order. So they also pick a range that matches a range of available liquidity, of available kind of traditional Uniswap V4 liquidity, which is called positive liquidity. And let's see how this works. So basically, if we kind of look at a normal range order, what would typically happen is, let's say the ETH price starts at 2,500. So if somebody has positive liquidity in the range from 2,000 to 1,500, as ETH price drops, they're basically putting up USDC. And then if we kind of get through if we cross their range order, we're going to end up, they're going to end up holding that Ether. A negative range order works the opposite way. It's putting up ETH and it's going to end up with USDC. How? Well, this is where the hook comes in. When a swapper makes a trade, priority is given not to the positive liquidity, but first the negative liquidity is being traded with the positive liquidity. So basically, LPs are getting slightly less swap fees because instead of the swap being the first priority is for the negative liquidity to be converted, and that's for the sake of the lender, right? Because the lenders need to be getting back the USDC that's converted. So Question here is, why would liquidity providers sign up for this? Why would liquidity providers reduce the fees and basically reduce their effective liquidity that's being exposed to swappers? Well, they do get a benefit, and that comes through the form of this liquidation decay fee, where as soon as we're starting to enter this liquidation range, borrowers start to pay out to liquidity providers. And this is equivalent basically to a sort of traditional liquidation penalty in other lending protocols, except it's a more continuous fee. So this provides another unique incentive to liquidity providers. Instead of just getting fees, they're now getting this liquidation decay. In the original article, they also described the idea of adding the ability for liquidity providers to lend their idle liquidity, right? As we know, before we enter the range of liquidity, there's liquidity potentially on both sides being available and underutilized. So that's going to be another extension. But for now, it's very simple. There's lenders that provide the capital in exchange for interest rate. There's borrowers that provide negative liquidity, which basically ends up being the same as just putting up collateral in one of the pair's tokens and then borrowing the other pair's token. And then there's the liquidity providers, of course, that will facilitate that, because without the positive liquidity, I don't think you're able to put up and start borrowing. So you need both the lenders and the liquidity providers to be there before borrowing can occur. So hopefully this is interesting. I'm looking forward to find out more information about this protocol as it comes out.